In this video, we're going to discuss a new concept, a concept of class friends. There are two types of friendship that is available. A friend of a class could be another class, or friend of a class could be another function. So let's discuss this concept a little bit. Imagine that I want to be able to debug this point class. So I want to see how it behaves, and it's part of the graphical user interface. So I normally don't have a simple terminal console available. However, in my debug sessions where I want to debug my application and determine if everything works correctly, I'd like to be able to open the console window and be able to print some information for tracing the performance and checking some states. So how about if I want to make a function that is very simple, and the idea is to print point. So this is strictly for debugging purposes. So if we want to print this point and pass a point by pointer, just say pointer to point. So this function should be pretty simple. So the idea behind this is to go to the implementation file right here and be able to print the point just like this. We could use standard output and simply display X . And likewise, we want to be able to display Y. I just print this on new line right here. And when we have a pointer to an object, as this argument of our function is, to be able to access members of that object, we are using this arrow operator, which instantly dereferences the pointer and provides access to its data members. So instead of using the dot operator, which was member access operator when using a normal object name, in case when you have a pointer to an object, like in this function, what we must do is with pointers, we have to use this instant pointer dereference to operator that allows us to access members of that object. So anyway, so this is where I'm printing this information for strictly debugging purposes, and perhaps I can also add the new line printed. And at the end of this output, and this is strictly for debugging, you should immediately begin to sense that because this is just another function in our application, it wouldn't be possible to access X and Y. There will be access control violations. So for instance, if I include IO stream, so cout becomes available, right? So include IOStream at the top of point.cpp. Then we still have this problem when we build the program, that same access control problem. So what would be my choice then? Perhaps I could take this function and make it a member of my class. But I don't even want to keep this a member of my class, because this is only used for debugging purposes. So it has very narrow type of use in my application, and I don't want to pollute my interface with unnecessary public functions, which will be basically confusing the clients of this class, because this is not really part of public interface. So the solution is very simple: to break the encapsulation rules and allow this function to access private member variables of this class. You can just, like anywhere in this code, you just copy the declaration of the function, paste it inside the declaration of our class, and add friend in front of the function declaration. Very simple. You don't have to place this declaration on top of class point. It can really, this could exist anywhere you like, and you just add this a friend declaration inside the point class. So friend or friendship in general is achieved by this keyword, and it's just basically placing a declaration of another class or another function and adding friend in front of it. And all of this is happening inside your class. So this tells the compiler, don't worry about situations like this. This function is a friend right here. You should allow direct access to private members. So now if I build this program, you see that compiler no longer enforces encapsulation rules on these two lines, where I'm using a function which is not part of my class, but it is still able to access private members of this class. So generally speaking, I would put friend declarations right at the top of class declaration to make these friends quite visible in inside the class declaration, to just indicate that these functions and classes that also can be friends of this class are able to access the private data members. Just a few rules to summarize the behavior of this friendship. A friend, such as this, gets full access to private members of the class. However, it is not part of the class, right? Because this is a function which is declared outside of the scope of our class. Friendship is a one-way street. Friendship is not symmetrical. A class can have no access to its friend. In other words, if I had another friend right here, friend screen, which represents computer screen, for instance. And by the way, I need to specify what is it. It's a class, right? So I have another class in my application named screen. Declaring this screen to be friend of this class does not mean that this class can access private data members inside the screen. So the friendship is not symmetrical. Screen will be able to access the point. However, point will not be able to access private data members of screen. So class has no access to its friend. The friend of my friend is still a stranger to me. Friendship is not transitive. Suggestions: prefer making functions friends rather than classes. Yeah, because you see, the whole idea behind friendship is that it breaks the encapsulation rules. All of a sudden, this function can do anything it wants with the internal implementation of this class. So it's easy to trace the functionality of a single function and see what it actually does do within the class, as opposed to give a friend access to the entire class with many different functions, which will now be able to do anything it wants with the internal state of this class point. So this is a much wider permission to break the encapsulation rules. This is why we say let's prefer making functions friends rather than other classes being friends. Declare friends on top of class declaration simply for clarity, because knowledge about friendships are very important to whoever is working on this class, to realize that there are some other parts of this application that are capable of doing anything they like with internal implementation of this. And don't make friends lightly, which means that don't do this without good thinking about it. You would probably want to enforce encapsulation rules as much as possible, and those things should be viewed as totally exceptions to this rule. So like my excuse for print point being a friend here is that I'm only using it for debugging my class, and this is like a lonely isolated function which is just allowed directly to access the internal state of the class, because I'm just using it to modify and debug it and use it in my debug sessions.